Examine the distribution in the below. Not a proper English sentence, but let's go with it. It shows the percent of subscriber that are in each class as opposed to the frequency distribution in the previous table. So if you look right here, right there, this is the percent of the people. So how the heck did they get the percent of the people? Well, if you read the previous problem, you have to see how many people were there. So for instance, I'm going to the previous page right now. I'm looking at the frequency distribution chart, and from 0 to 5 seconds was 6 people. Well, there was a total of, if you read it, it doesn't really say how many there were, so I'm going to go ahead and add all of them together. The total number of people, I'm just going to write this over here so you can see it. The total number of people was 1,000 people that took it. So for instance, if I do 6 divided by 1,000, that's 6 people took 1 to 5 seconds. If I do 6 divided by 1,000 in my calculator, I get the 0.0006, right? That's 0.006, okay? But that is a decimal version. I need to convert that to a percentage. So I take that number and convert it to a percentage by multiplying by 100, or just use the percent conversion on the thing. And that's where I'm getting the 0.6%. So how did they get all these numbers in the chart? They took the number that was in the chart, the frequency, divided it by the total amount, which was 1,000, converted that number to a percentage. So this number that you see right here is the percent of the total people that they did. So what's the idea? They had 6 people take between 0 to 5 seconds. But remember, this is a sample group. It's not the entire population. It's just a sample. And we want to use that inferential statistics where you take the data for the sample and you say that's what it is for the entire group, the entire population. So the way that you can take data from a sample and turn it into data for the entire population is change it to percentages. So instead of saying 6 people took for this, they're going to say 0.6% of our subscribers, the entire population, took this long. So for instance, 15.1% of subscribers took between 20 to 25 seconds. So again, they're now taking the data from the sample set, converting it to percentages, and that's what they're going to infer that it works for the entire population. So now we can use this data for the entire population. A lot of this is going on right now with COVID-19. They're taking the data from those who are tested, and then they're using that as a percentage of the entire population. So you're going to see very small tested data sets. 5,000 people got tested in a population of 100,000, and they're going to say 4% of those tested had COVID. So then they're going to say 4% of the entire population had COVID. So that's how they're working right here. They take the numbers, convert it to percentages, and then use those percentages to talk about the data sets. Okay, sorry about that. Let's get back to this. It says examine the distribution in below. It shows the percentage of subscribers that are in each class as opposed to the frequency distribution in the previous table, which shows the number of customers in each class. The type of frequency distribution in the list of percentage in data is also called a relative frequency distribution. So that's what we're dealing with now, is a frequency distribution. They call it relative because it's relative technically to the sample, not the population, but that's fine. It says the relative frequency distribution was drawn by using the data in the frequency distribution. It shows the percentage on the axis. So if you notice over here, now we're talking about the percent. We're no longer talking about the actual frequency. Again, I want you to notice the shape of this. To get the shape of this, we're still dealing with what we call a bell curve. It says one advantage of using a frequency distribution instead of a grouped frequency distribution, a relative frequency distribution instead of a grouped frequency distribution. In other words, one of the advantages of using percent instead of using the quantity is that there is a direct correspondence between the percent values of a relative frequency distribution and probabilities. So remember, when we wrote probabilities, we could write them as decimals. simplified fractions, or percentages, any of those three ways. Well, now they're going to start writing probabilities as percentages. So just be prepared for that. They can also write them as decimals, and they can write them as fractions. Just remember, with probabilities, your answer is always between 0 and 1. It says, for instance, in a relative frequency distribution above, the percent of data that lies between 35 seconds and 45 seconds is 14.9%. So it says, thus, if a subscriber is chosen at random, the probability that the subscriber will require at least 35 seconds, but less than 40 seconds to download, is 0.149. Again, you could write it as a decimal, a fraction, or as a percentage when you're talking about probabilities. Here they chose to write it as a decimal. Okay, so let's see here. It says example 1. Use the relatively frequency distribution above to determine the A, percent of subscribers who require at least 25 seconds to download the file. So we want at least 25 seconds, so that means 25 seconds or more. At least 25 seconds, so 25 seconds or more. So what am I looking at? Well, it seems to me that I'm looking at every single one of these numbers right here. So what would I do at that point? I would take all those numbers, 19.2 plus 19.0 plus 14.9 plus 9. I can't do the plus dot 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 on this because there is no pattern to continue. So I actually physically need to show everything that I'm doing. I'm going to add all those numbers together. Please do so now. Double check my math on this one. I'm getting 69.1%. Please let me know if that's what you got as well. So for part B, it says probability. Find the probability that the subscriber chosen at random will require at least 5 seconds, but less than 20 seconds. So let's use a different color for this one. I'll use my purple pink. So it's at least 5, but less than 20. Let's see if we could find that out here. So at least 5, but less than 20. I'm going to look at the quantities here. Here's at least 5 seconds. All the way to here is less than 20. So how are we going to find the probability? Let's go ahead and add those percentages. 1.7% plus 4.3% plus 9.2%. Add those together on your calculator now. Please double check my math. I'm getting about 15.2%. 15.2%. And if that's the percentage, if we want to convert that to a probability, just convert it to a decimal. So just divide it by 100, or you can use the percent button on the calculator. It'll change it to a decimal, and you end up with 0.152. So you're just moving the decimal left 2, divide by 100, or use that percentage calculator on the button, and you'll get the quote-unquote probability. So when they're asking for probability, I apologize earlier, I said they'd be using percentages. They're not. They're using decimals, it seems, in these examples.